Awesome. So in theory now, we should be live. Are you able to confirm that? Or as I can... Perfect. Do it on your Okay, sweet. Yeah. So last week we kind of gave a quick introduction of what CTFs were and what the club did. And we talked a little bit about this thing called Fairgame, which is our annual internal CTF that we run, which is intended for beginners. And it looks like a number of you have gone through and you've really made great progress there, plowing through a bunch of those challenges. But we want to make sure that everyone kind of has a little bit of a background here going in first, and they kind of know what to expect. And so to make things easier, today for this talk, we've decided to just go through and do all of the easiest level challenges possible. So we're doing all of the 100-point challenges. And then we're leaving the upper level challenges for you guys to figure out on your own. So you still have a puzzle to be working through. We're not taking away all the fun, we hope. But just making sure that everyone kind of knows how this process works. And with that, do you want to kick off on the web, Dylan?
I will, sure.
Awesome, perfect.
Oh, eventually.
Yeah, it's macOS. You gotta.
Oh, you gotta.
Do
Who is it?
Go up. It's
Oh,
hiding
get a
behind.
fancy one. Got it. Okay.
Exactly.
Obviously, I don't use Mac. Anyway, if we go to the web one, we can see it has this little blurb. Nothing about it looks anything particularly useful, so not really worth mentioning too much. We look at the page, and we can see that we have what looks like a login. And if we try just random stuff, you can see it actually is checking. So we do need to find some way to do it. When I'm doing a web challenge, one of the first things that I always do is I'll look in inspect element or page source. It really depends. I just tend to like inspect element. When we do that, we can see all of the code that is being run on our end. This does not show us anything being done on the server side, but it shows everything the server sent to our computer. And what we can do is if we look through, we can immediately see this links to two JavaScript files. One is this auth.js and one is this db.js. Auth is probably the actual backend logic being used to actually check. DB is probably short for database. So what we can do, because like I said, this code is being run on our computer, it means our computer has access to this file. So what I can do is I can say copy the address of that file. Where is it? Copy link address. Open up a new tab. If I go to it, you can see it shows us what looks to be a username and a password. All we have to do is just take that username and that password, and it should hopefully give us a flag. Special characters. So we try that and log in. We can see it was valid, and we have a password. We have a flag right here. So we just take that, copy it, head on back, and this flag should work. That's how you do Web 100. Are there any questions on how that worked? We have the chat open if anyone has questions.
Awesome.
Taking that as a no.
And then I'll be continuing to watch the chat as Dylan does his walkthroughs, and he'll be watching it as I do mine. So if you have any questions, don't feel like you have to be waiting for us to stop and ask. Feel free to just type them in, and we'll get to those as soon as we can. Sure, go for it. Let's just go straight down.
Yeah. So going through the list, next we have crypto, which you can see is talking about using Shirley's time machine to go back in time and found a cryptic message from Europe, and it has a link to a file. We already downloaded that file, and we have it open right here. So you can see this does not really look to be anything legible. Obviously, it's some sort of crypto challenge. Oh, we see one comment. VirtualBox is running super slow and keeps crashing.
So sometimes that can be an issue with the resources that you've allocated to it. So maybe if you haven't allocated enough memory, or if you've allocated too much memory, those can both lead to issues with VirtualBox with it being really slow. Because if you haven't given it enough, then that virtual machine can't operate. And if you give it too much, then the computer that you're running the virtual machine on can't operate. If you give us more details, like in the Slack or something like that, we should be able to help troubleshoot a little bit more. Jeff knows what's up, yeah.
I believe that is it for now. So looking at this, one of the first things that I can see is that it is pretty much definitely not any sort of public key cryptography scheme. Crypto schemes come in mainly two forms. You have public and private key. The reason I know it's not a public key is because, one, there were no public keys mentioned, and two, because public key systems, as far as I know, all of them work by translating the message into a number and then doing math on it. This is very clearly not a number. This is still text. So I know this must be some sort of private key system. Additionally, I can see over here that this section, everything after this colon, looks like what the flag ended up being encrypted to. And I can see that because it has 4 letters followed by curly braces, and inside the curly braces has a little string of text in there. Because I still see it like that, I also know it's not going to be some sort of block cipher like AES or DES, because otherwise that would have been mixed up in the blocks. So I know this is probably some sort of really old historic scheme, which was also hinted at inside the actual challenge description, where it talks about using a time machine to go back in Europe. So that leads me down 2 paths due to the way it is set up, which is it is probably either a Caesar cipher or a Visionaire cipher. And what I can do, if you remember from the toolbox talk that Stephen gave the other day, there is this Swiss Army knife of,
Let me just save the dark mode too. I think it's going to look a little bit nicer.
Oh, yes.
That works.
There was a Swiss Army knife program of just general cyber things called Cyber Chef, and it has both of those built in. So for example, if I take it in, this is the input we were given. Obviously, I'm not doing anything to it. I'm going to say it's probably a Caesar cipher, just based off of the expected difficulty, as well as the fact that it specifically mentions a cryptic message in Europe, where it's named after Julius Caesar, who was a well-known European leader. So if I just go here and I start typing in a Caesar cipher, on here therefore there is a Watt 13, where a Watt cipher is where it takes everything and rotates it by a certain number. So for example, if you had a Watt 1, an A would become a B becomes a C, and so on and so forth. The standard Caesar cipher is Watt 13. However, it's not necessarily what was used here. So what I'll do, the reason why this cipher is not remotely secure is because there were only 26 possible keys, really 25, because if you rotate 26 times, you're back to where you were. So you only have 25 possible keys, which means I can just set this to 1 and say, okay, this isn't right. What about 2? What about 3? And I can just keep going through these until I see something that looks about right, which we can see right here, with a shift amount of 10, we get what appears to be a flag. We can just copy that and test it out.
Oh, we need to reload there.
Yes. Some technical difficulties, unfortunately. However, I can tell you that is the actual flag. So if anyone has questions on how we got to that, once again, ask in the chat whenever you have questions.
My computer often gets a little bogged down when we're trying to stream here, so I believe that's what's going on at the moment. But yeah, as you could see from that challenge, we were able to get a flag out of that. We did get the proper flag format. And so even though my computer's a little bogged down and seeming to have some issues here connecting to the outside internet, you could see that that was the appropriate flag.
I guess, would you like to go on to one of the other challenges?
Sure. So if I remember correctly, the next challenge in that list was MISC.
Yes.
And we named that challenge Slack Dweller because that challenge used to be named Basement Dweller. And the goal of that challenge was to essentially go through and find this little room that we have in the basement of Amos Eaton and figure out where our club room was, and we could give you a flag through that. However, because of the current COVID situation, we wanted to make sure that A, that was going to be accessible to everyone, even if they weren't in Troy, and B, like, you wouldn't have to potentially go onto campus at a time when the administration wouldn't want you going onto campus, because when we first started this semester, we were actually not allowed on campus due to the quarantine. And so we've updated that to kind of point everyone towards the new way of interacting with the club, and that's through our Slack. And so if you join our Slack, the URL is rpisec.slack.com. Anyone with a RPI email should be able to join that just fine. And you can see we have a Fairgame channel here. We talked about this a little bit in one of our first emails. We talked about this in our first live stream even, I think. And we've just put a little flag in the topic of that Slack channel. So this is a great place for you all to be coming in and to be asking questions about Fairgame or anything like that. That's actually why we made this. So we want to encourage you all to be coming into this channel and asking questions. And the way that we did that was by giving you a flag for doing it. So we bribed you there. Looks like my internet is still having some issues there, unfortunately. But assuming that there are no further questions, it looks like the next challenge category here is reverse engineering. And so the way that, that this challenge works, if we look in here, we go into the, we see that there's a binary here. And if we run that binary, we can see that it asks us for some serial number. And please enter the serial. And if we don't have the right serial number that it's expecting, it's just going to say invalid serial, and it's going to deny us access. So we need to somehow figure out what input this is expecting. And the typical way to do that, when you have some kind of executable file like this, we can see if we run file, which is one of those commands that Stephen was talking about to give us a little bit of information. It's a 64-bit ELF. And what that ELF means, that's an executable, linkable format there, yeah. And so that's just some kind of Linux executable, some kind of program that runs on a Linux virtual machine. Or on a, like the tools virtual machine or any other Linux installation there. And so one of the tools that you use really commonly to take apart those kinds of files is something called Ghidra. And this is totally free, this is available, this is open source, and this is actually even installed on that tool's virtual machine. So I just want to show you how to run Ghidra, because it's a little bit unintuitive here. You do need to run this Ghidra run script. And once you do that, you should have a little box that pops up in a couple of seconds with a fancy logo of a dragon in it. Like I said, my computer often gets a little bogged down when we're streaming just because it can't handle recording my screen and then shooting that out onto the internet. So there it is. Okay. Sweet. But yeah, you can download this for free if you don't have the Tools VM. As you can see, I'm running it on Mac OS, it runs on Windows, it runs on Linux, it runs on basically anything.
It's Java, it runs on literally anything.
Yeah, exactly. So it's going to take a couple of minutes here to open up. And I've just gone through the trouble of making a project already, but if you haven't done that yet, you can make a new one by going to File and then New Project. I've named mine Fairgame, and then you can hit I to import a file. I'm just going to import that RE100 challenge. It's going to take a couple of seconds to go through, and then it's going to have a little bit of information here. So just saying like what the platform is, how it was compiled, and then what we want to name it basically. So we can just hit OK, because all of those defaults are totally fine. Ghidra is smart enough to figure out a lot of information on its own there, which is great. And so it's going to kind of do a little bit of analysis really quickly. It's going to spit out some extra information on how this program looks. And then you can just double click it. You get that cool little animation there. And it should open up in what's called the code browser there. And then it's going to say that it hasn't been analyzed yet. Would we like to analyze it now? We can just hit yes. Again, all of these default options are totally fine. We can hit analyze. Just close VS Code there. And after a couple of seconds, this should start to be populated a little bit more. In the meantime, though, we can start looking through some of this other information here. We have a list of functions. By default, this is going to be on the left in this little window. You can see there's one named main. So I'm just going to kind of jump ahead on my own here, jump into that main function. And it's going to kind of show us on the left here the disassembly. So this is what your processor is going to see, basically. This is going to be directly correlating to the bytes that gets executed on your CPU. And then the really, really cool thing about Ghidra, the thing that makes this so special that it's like friggin' open source, is that it even has a decompiler. And so this is going to be a little extra program that runs on top that just analyzes that assembly, and it's going to give us something that looks a lot more readable to a human. And we can see it's printing out these strings that we were seeing before, the welcome to the revision 100 lock, please enter the serial. And then we can even see down here, it's calling stir compare. And if you're not familiar with C, this is a function that basically compares two strings. So we can see the first one is probably going to be whatever like we enter as a user, so that like completely valid serial number, or whatever string we decide to put in there. And the second number is going to be this flag. And so we can just copy that out, and we can actually see here that that flag says sometimes strings is all you need. And that kind of brings me to another way to solve this challenge that I wanted to show you real quick. I think on Tuesday, Stephen did a really good job of walking you through some of the like built-in tools that come with Linux, so some of the like basic command line things. And one of those was this utility called strings. And so if we call strings on RE100, we're going to get all of this garbage that's like not super readable to us, like these like glibc versions and things like that. However, he also talked about another tool called grep. So we can just grep for that flag, and we can see that that spits it out just the same. So that's kind of two different ways to solve that RE100 challenge. Kind of up to you how you want to tackle that one. And then the last challenge that we want to walk through is Pwn 100. So if we just cd into that directory, we can see we have two files that are accessible to us. So we have that C file, so that's going to be the source code, and then we also have the binary. We run file on it. Again, we can see that this is an ELF, so this is an executable. And if we run it, oh, you know what? So this is actually something that when you first download these files, you might have trouble with as well. And that's that we haven't marked these as executable. So we can do that with chmod plus x, and then the name of the program. So now, when we run that, it should run just fine. So we know that when we run this program, it's going to have some fancy little coloring here. It's going to say, welcome to the rewards point program. It's going to give us a version, and it's going to ask us for our name. So my name is Rylan, and it says that I currently have 0 reward points. Once I get up to this number, then I'll win a prize. And there weren't really a lot of other ways to interact with this program, so we need to find some kind of tricky way to make this do something that it wasn't intended to do. So if we look through that source, vim pwn100.c, we can see here these are the printf statements, so that's where it's going to be printing out like the welcome message and prompting for the name. And we can also see some weird looking things here, and that's basically just telling your computer that you should be changing the color for that text. And then right on this line, we can see that it's calling gets foo. So that's going to be how it gets that user input into the program, into memory. We can see foo is this array of 20 characters. And then down below, it checks if points is equal to ox leet dude. And if so, it gives us a little message saying we did it, and it gives us a shell. It runs bin sh. And otherwise, it gives us that that message saying that we don't have enough points. But as you can see in this program, the only variable we can interact with here is foo. There's no way that we can change points. There's no way that we can like assign another value to points, or at least not directly. So just for kicks, let's take this and let's try to run that compilation. And when we do it, when we try to compile that source code that's provided with the exact same flags, with the exact same arguments, we can see down at the bottom here, it says, warning, the gets function is dangerous and should not be used. So that should really be a big red flag for us. And I threw together a couple of slides just kind of explaining the basic idea of how we can use that gets function and why that gets function is dangerous, so that we can modify that points value. And so right here, I just have a basic visual representation of the stack. If you've taken data structures, this should look pretty familiar. If you haven't taken data structures, or if you're taking data structures right now, this will probably make a whole lot more sense once you get to that point in the semester. So if you're looking at this and you're saying, oh my god, this doesn't make any sense, that's probably why. That's because this is kind of assuming a little bit of knowledge that you may not have gotten to in your curriculum yet, and that's totally fine. But we can see that on the stack here, we have foo. So that's that string that we get input into. And we know that's 20 characters, that's 20 bytes. And then right above it on the stack, we know that there's that points variable. So it's right next to foo on the stack. Now, what's so interesting about gets is that, yeah, sure, it lets us get information. It lets us get user input. So I can put in a string like Rylan, and that's, 1, 2, 3, 4, 5 characters. But we have 20 characters allocated. So that's still totally fine. That points variable is still going to be 0. We're not going to be changing the value. However, when I start throwing in a ton of characters, so if we have 20 characters allocated for that buffer, for that array, and instead of putting in, 5 characters, if I put in 50 characters, well, let's see what happens then. So I am extremely lazy, and so I don't want to have to type out 50 A's. So I'm going to make Python do it for me. Oh, that's 50. We copy and paste it in, we can see, well, sure enough, that value did change exactly like we were expecting up here, because that points variable is right next to the foo variable on the stack. And so once we fill up foo, that's going to overflow into the points variable. We can see that's exactly what happened here, where we overflowed into that points variable. And then we actually overflowed too much, and it caused it to seg fault there. But we know that if this points, or if we know that the foo variable is exactly 20 characters long, what if we do that same trick, but instead of writing out 50 A's, what if we do 21 A's? We can do print A times 21. It's going to give us 65 points. Now that may seem like a kind of random number, but if we hop back into Python here, and we do a hex of 65, we can see that's 41. And we also can convert that number from an integer, like it is at the moment, into a character. And so we can do that with CHR in Python. And say 65, CHR of 65, is in fact A. So that's where that point value is coming from. So we know that we can control that point value, and we can make it whatever we want. The issue is we need to set this equal to that leet_dude string. And so not all of those bytes are going to be valid characters. Like, we can't type out all of those bytes on the keyboard. And so we're going to need to find another way to do that. Luckily for us, there are ways that you can do that in Python. So when this challenge was written, Python 2 was still kind of the go-to. And so this is actually much easier to do in Python 2. Because Python 2 is really, the way that it handles like raw bytes and low-level information like that is really incredibly convenient for us. So we can just do Python inline here with the C flag, and we can say print, and then say if we want to print OX41, we know OX41 corresponds to an A, we can do \x41. Oh, and then it helps if we even close the quotes. And we can see that does, in fact, give us an A. So we can interface with those bytes directly. So I guess one other thing that I want to show you guys real quick. Remember, piping is a way that we can pass the output of one program into the input of another. So we can do we can pipe the output of this Python print statement into the input of that rewards program. And we can say, if we do 20 A's, and then we know everything after those first 20 A's are going to be overflowing into that points variable. So what if we do 20 A's and then B, C, D, E? If we run that, we can see that our current points is this value. When we run Python, we convert that to hex, we can see that's 45, 44, 43, 42. And we know, for example, CHR OX for 2, that's going to be B. So the way that the computer is reading this, it's seeing instead of the points being B, C, D, E, it's seeing E, D, C, B. And so it's kind of backwards of what we would expect. And if you've taken this class called CompOrg at RPI, or if you're going to a different school or something like that, if you've taken whatever the equivalent of that class is there, you may have heard something called endianness. And we know that our computer's a little endian system. Actually, if we run file on that rewards program, it even tells us that's LSB. That's a least significant bit executable. And so that's just going to mean, for all intents and purposes, for all that we care about, that's just going to mean that the way that it's going to look at these numbers is going to be backwards. So we need to find a way to flip the bytes. So if instead of doing B, C, D, E, if we put together all the stuff we've just been talking about and we use those escape strings, those hex strings, we can do /x, OD, DO, 37, 1, 3, like this. You have to do this. There we go. And we can now see we have the exact number of points. Of course, this solution kind of relies on us using Python 2 instead of Python 3. And so I wanted to show you the solution for the sake of completeness, but I want to recognize that there are also a lot of other ways to do this, and there are a lot of ways that going forward may be kind of easier to do instead of having to install Python 2. And so the other way that I wanted to show you is by using this library called PwnTools. And if you're using the tools VM that we've provided, PwnTools is already installed for you. If not, it's very easy to install with pip. So I'm just going to make a quick script here. We can import PwnTools. So from pwn, import star. It's going to import everything from the PwnTools module, and we can make a process. So p equals process, and then we just give it the name of that executable. What's that?
Who was program?
What did you say?
Who was program, not binary.
Oh, gotcha. Good catch, Dylan. And then we can just send input in pretty much the same way. So we do p.sendLine instead of piping. And then we send it that same exact string. So we can do a times 20, and then we can also do another really cool trick. This is specific to PwnTools, but it has these functions to help you pack information a little bit more easily. So I'm using this function called p32, which will pack it into an integer, basically. We can pack in ox leet dude. And a really, really cool thing about this packing function is that it handles that endianness for us. And then the last thing we want to do is we just want to tell this to be interactive. So this will let us interact with the program after we have sent our input to it. So if we just run that really quick, starting that, and then we can see the number of points lines up exactly, and it says we did it. And we do, in fact, have a flag. So the one last little tiny thing I want to show you how to do is PwnTools actually makes it really, really easy to interact with remote systems as well. And the way that it does that is through another function called remote. And from there, we can just paste in the address of this, which is chals.fairgame. Oh, this has got to be a string. chals.fairgame.rpis.ec. and then the port number, so that number afterwards in our Fairgame documentation is just 5001. And now when we run it, we're now running this against the remote system. You can see the number of points lines up exactly the same again, and it says we did it. We do, in fact, have a shell, and you can see that there's a flag there. I'm not going to cat that flag out right now, but if you're watching this video, you can follow along after the fact. This will be posted as a video on demand, so you can follow along at your own pace. And you can follow the exact same steps as me to be able to exploit that program on your own and get that flag for yourself. So yeah, that's it for walking through the Fairgame challenges. The one other thing that I really want to talk about is this other CTF called Seesaw. So if you've been playing Fairgame, or if you've just gotten into Fairgame with this talk here, and you want to try your skills on another CTF, we're playing Seesaw qualifiers right now. And if you are an undergraduate student, this is only open to undergraduates, and you're welcome to join our Slack, and we have information for competing alongside us with in this CTF. And this is usually a very, very good CTF to get started in. So this is how a lot of our members actually originally got started with the club, because many of the challenges in Seesaw are very, very beginner friendly. So I highly encourage you to hop online and to come play with us if you are so inclined. I think that's it for us today, but thanks for tuning in.